we'll practice. We'll carry on and we'll practice to find out oxidation states. Look at these compounds. MgF2, you want to place the oxidation number. First thing first, it's a neutral compound. It's not a polyatomic ion. So overall oxidation number is 0. Then the simple rule that group 1 and group 2, group 1, lithium, sodium, potassium, rubidium, cesium, francium, even hydrogen. And group 2, beryllium, magnesium, calcium, strontium, barium, radium. Whenever you find them, put the oxidation number first to them, +2. Group 2 it is +2. Now fluorine, we know it is group 7. Oxidation number, I said, mostly matches valency, -1. This is -1 into 2. So overall it is -2. Sum of oxidation state is 0. Straight away, magnesium is +2. Fluorine, F2 here is -2. F is 1, -1. Sodium oxide, overall oxidation number is 0. Now sodium, group 1, I said assign group 1 first. Rule says first to group 1 and group 2. +1 into 2. It makes it +2. It means oxygen must be -2 to make it 0. Look at sodium chloride. Overall oxidation number is 0. Sodium +1, chlorine -1. Oxidation number is what? Overall oxidation number is 0. H2O, oxidation number is 0. But here you need to be careful again not to touch oxygen, because group 1 hydrogen stays. +1 into 2, +2. Oxygen is what? -2. Copper oxide, overall is 0. We don't know the coppers. It is a transition element. And you know transition element varies in oxidation number. We are not sure about it. We are sure about oxygen belonging to group 6. It is -2. Then it is copper what? +2. Okay. Even sometime another example can be Cu2O. And you find out oxidation number. And you'll find out that oxygen need to assign first, because group 6 -2. Then it is +2. But +2 of 2 copper atoms. It means originally copper is +1 here. Okay. So sometime you will find out a situation that they ask you to write the systematic name, or you read systematic name. It is written like here, it should be written copper 2 oxide. And they ask you to drive the formula. Instead I will say, okay, copper 2 oxide, it means I will place copper +2. Thank you very much. It is written in Roman, and oxygen -2. So straight away +2 -2, and overall is 0. It means, or in other way, you drive the formula Cu +2, oxygen -2, swap it around and cancellation. Oxidation number is, sorry, the formula is CuO. It means systematic name can also be derived out of the oxidation number. Look at this. Now here we know it is copper Cu2 +2. It means it should be copper 1 oxide. The reason is 2 of the copper atoms have an oxidation number of +2. It means 1 should have +1. So even we can write a systematic name placing on the oxidation number. Now hydrogen peroxide, mostly bit challenging for the students. Hydrogen peroxide, we know, follow the rule, overall oxidation number is 0. Then you need to stick to the fact not to touch the oxygen. It is group 6, group 2, group 1 first, group 1 or group 2. This is group 1, hydrogen, +1 into 2. Oxygen is -2. So it means one hydrogen atom has an oxidation number of +1, because 2 of the hydrogen atom has an oxidation number of +2. So this is hydrogen peroxide. In other way, if we find out, like sometimes the student make mistake like H2O2, this is hydrogen peroxide, and they put -2 into 2 -4, and they stretch hydrogen to +4. That's not possible. Hydrogen cannot have an oxidation number more than +1. So this is not the right way basically. Look at copper chloride. Overall oxidation number is 0. I said transition element, we don't know, but we know group 7 -1 into 2 makes it as -2. 2 chlorine atoms -2, 1 chlorine atom -1, copper +2. Okay, even this can be written as, because copper is a transition element, you can write it as copper 2 chloride. Normally it is a stable compound, copper 2 chloride, but copper oxide can be copper 2 oxide, black color, or copper 1 oxide. Okay, look at potassium iodide. Overall oxidation number is 0. Now potassium belong to group 1 +1. Iodine belong to group 7 -1. You noticed I assign potassium +1 first, because group 1, group 2 oxidation number is fixed almost. Place it first. Look at calcium bromide, overall is 0. Since it is group 2, assign first +2, it is -1 into 2, and that makes it as -2. So overall oxidation number is 0. So these are pretty simple examples, but we always remain careful that group 1 must be assigned first. And if it is a transition element, then we need to wait. We'll assign the other one first. Okay. So some of the oxidation numbers were 0, and we relate the group numbers, we relate the element to their group numbers, and we placed. So in all these examples, oxidation numbers are mostly matching the valency. Okay. But here, this is not a stable compound. You know that wherever hydrogen peroxide is placed, it breaks quickly to H2O and O, and oxygen is obtained out of it. Reason? Because it's not a stable compound. Oxygen is not having a normal oxidation number. O2 -2. It means one oxygen has an oxidation number of what? -1. Normally the oxidation number, the stable oxidation state of oxygen is what? -2. But it is unusual. O2 having -2 means one O has -1. So hydrogen peroxide is not a stable compound. You open its bottle, you'll find out that it's breaking up into oxygen and water. So it's not that stable. Okay. So oxidation numbers of some of the simple compounds are practiced here. We'll take some more examples. Pause.